Welcome to The Explainer. Today, we're going to get our hands dirty with one of the most important steps in modern software development, taking an AI chatbot that works on a laptop and getting it ready for the real world using Docker and Kubernetes. You know the feeling, right? It's the classic developer line, well, it works on my machine. An app can run perfectly on your laptop, but getting it to run reliably out there in production, that is a whole different ballgame. Today, we're going to bridge that exact gap.
Okay, so let's dive right in. To really get this journey, we first have to understand where we're starting from and, exactly where we're trying to go. So let's define the mission.
So, what are we working with? We've got a complete full-stack AI chatbot. It's built with some pretty cool modern tech. Next.js for the front end, FastAPI for the back end, hooked up to a Postgres database and an Ollama AI model. And the most important part? Everything is already working perfectly in a local dev setup.
So what's the game plan? Our objectives are crystal clear. First, we need to wrap our front end and back end into Docker containers. Then, we're going to deploy them to a Kubernetes cluster. Now, to make this easy, we're going to be using a tool called Minikube to run that cluster right on our local machine. We'll also have to get all the networking and secret variables configured correctly. The big idea here is to create an automated process so we can do this over and over again, reliably.
All right, let's get to the first big step. Before we can even think about Kubernetes, we have to prep our application. We need to create its deployment blueprint, and that means writing our Docker files.
Now, what's really cool here is seeing the different strategies for the front end and the back end. For the Next.js front end, it's all about creating a super optimized static production build and then serving it up. But for the FastAPI backend, the Docker file is focused on something else, starting the server correctly and being ready to pull in configuration, like environment variables, when it starts up. Two totally different jobs, two different container strategies. So, with our app all neatly packed into containers, it's time to build its new home. We're not going straight to the cloud. Instead, we're setting up a powerful, local version of a production environment using Minikube.
And you know what? Getting this environment running is surprisingly simple. It's really just a three-step process. Install Minikube, start the cluster with one command, and that's pretty much it. Minikube is smart enough to automatically connect to kubectl. That's the command line tool you use to talk to Kubernetes, so we're ready to deploy right away.
All right, this is it, the moment of truth. Our containers are built, our Kubernetes cluster is running, it's time to launch. But as any engineer will tell you, the first launch rarely goes off without a hitch.
Now, to do this right, we're not just typing commands manually. We've got a PowerShell script that automates the whole thing. It checks if Minikube is running, points Docker to it, builds new images, and then applies our Kubernetes files to create the deployments and the services that let them talk to each other. This is how it's done in the real world.
So we run the script, it finishes, no big red error messages, but when we check on the status of our application, yeah, something is definitely wrong. The deployment didn't actually work.
And this is what we see. Our backend pod is stuck in the dreaded crash loop backoff state. If you've ever worked with Kubernetes, this image is probably giving you flashbacks. It means the container is starting, immediately crashing, and then Kubernetes just keeps trying to restart it again and again in a loop.
Okay, but look, hitting an error like this isn't a failure, it's just part of the process. The real skill is knowing how to debug it. So let's break down exactly how we got to the bottom of this.
We followed a methodical four-step plan. First, we confirmed the pod was failing. Second, and this is the absolute key, we used kubectl logs to just ask the container, hey, why are you crashing? Third, we looked at those logs to find the real problem. And finally, we applied the fix.
And boom. This is why you love good logging. Right there in the output, the application is literally telling us what's wrong. It's crashing because it's missing a super important environment variable, a secret key it needs for security. We just forgot to add it to our Kubernetes deployment file. The fix was actually pretty simple. We just added the missing variable to our backend configuration, ran the script again, and Kubernetes took care of the rest. It automatically replaced the crashing pod with a new one that had the right config. And this time, it started up perfectly.
So with that crisis averted and our pods all running and healthy, we can finally call this deployment a success. Let's take a look at the final working setup and make sure everything is running just like we wanted. So we run down our checklist. Are the pods healthy? Yep, both show one by one running. Is the networking set up correctly? You bet. And the best part? When we check the backend logs, they're just happily printing 200 OK messages from the health check. That's a successful deployment.
Okay, let's zoom out and look at the big picture here. At the bottom, we have our Windows machine. Docker Desktop is running on top of that, and Minikube uses Docker to create our local Kubernetes cluster. It's inside this cluster that our application now lives, as two separate pods. And from there, they can reach out to our database in the cloud and the AI model that's still running on our host machine.
So let's just recap what we really accomplished here. We didn't just get an app running. We successfully containerized a full-stack application, deployed it to Kubernetes, and, more importantly, we followed a realistic process that included automation and debugging a real-world error. And this brings us to the biggest takeaway of all. The source material says it perfectly. After going through this process, the application is fully ready for cloud deployment. By figuring out all the hard stuff locally, we built a solid, portable, and scalable blueprint that's now ready for the big leagues, any major cloud provider. This entire journey, from local code to a containerized app running in an orchestrated environment, that's the foundational work for launching any modern application today. It proves the concept and gets rid of a ton of risk before you go live, which really just leaves one final question for you to think about. What will your next deployment target be?